The Megalodon. Just the name is enough to send a shiver down your spine. For more than 100 years, our picture of this ancient beast has been shaped by one single terrifying feature: that massive jaws. But what if we were wrong? What if that was just scratching the surface? Science has just peeled back another layer of prehistoric time, looking past the teeth and into the very biology of the beast. And what they found is a game changer. It suggests that while we were all focused on its mouth, we missed the Megalodon's real secret. It wasn't just about the power to kill, it was about the power to endure. A stunning new discovery suggests the Megalodon's deadliest weapon wasn't its jaws. It was a secret hidden in its blood. So let's talk about the metabolic secret that might have allowed this monster to go for months on a single kill, and how that made it far more terrifying than we ever imagined. To understand this revolution, you have to understand the old picture it's replacing. For the longest time, a common assumption was that Megalodon was basically a scaled-up great white, but with the limitations of a cold-blooded fish. Most sharks' body temperature just matches the water around them. It's a low-energy, simple way to live, but it has drawbacks. Colder water means a slower metabolism, slower movement, and a smaller hunting ground. You're basically stuck in the warm, comfy shallows where life is easy. When applied to Megalodon, this model created a specific image. A giant, sure, but a giant stuck in the tropics. A king whose kingdom had very clear borders. Its huge size was seen as both its greatest strength and a possible weakness. How could a 50-foot cold-blooded predator possibly find enough energy to hunt the massive, intelligent whales that were its main food source? A predator that large, running on a cold-blooded engine, would seem sluggish, an ambush hunter just waiting for prey to make a mistake. It was a scary thought, but a limited one. This was a monster chained by thermodynamics. But the questions started piling up. If it was trapped in a warm water corridor, how did it achieve a global distribution, with its teeth found in oceans all around the world? How did it compete with the rise of new, clever marine mammals? The old model of a giant, slow, cold-blooded shark was starting to show some serious cracks. The evidence of its worldwide dominance just didn't fit. There has to be something else, and it turns out the clues were hiding in the only part of the Megalodon that really survived the ages: its teeth. But this time, scientists weren't just looking at their size. They were looking inside them. The breakthrough didn't come from finding a bigger tooth, but from a revolutionary new way of reading it. Scientists had debated Megalodon's body temperature for years, but a 2023 study in the Proceedings of the National Academy of Sciences provided some of the first empirical evidence. A team of researchers used a groundbreaking technique involving clumped isotope thermometry. It sounds complicated, but the idea is actually pretty neat. Think of a fossil tooth, less like a rock and more like a chemical time capsule. As an animal's tooth enamel forms, it locks in a signature of its internal body environment. Specifically, scientists looked at how isotopes of elements like carbon and oxygen were clumped together. The way these isotopes bond is directly dependent on temperature. It's like a tiny subatomic thermometer. By analyzing these bonds, you can figure out the body temperature of an animal that's been extinct for millions of years. The team analyzed Megalodon teeth and compared them to other smaller sharks, known to be cold-blooded, that swam in the same ancient waters. The results were electrifying. The cold-blooded sharks had body temperatures that matched the seawater, just as expected. But Megalodon was different. The data showed that Otodus Megalodon maintained an average body temperature of around 27 degrees Celsius, or about 80 degrees Fahrenheit. Crucially, this was significantly warmer on average, more than 7 degrees Celsius warmer than the water it was swimming in. This was powerful new evidence. Megalodon wasn't purely cold-blooded. It was an endotherm, generating its own body heat. Now, this wasn't the full-on mammal-style warm-bloodedness of a whale. Instead, it was what's known as a regional endothermy. We see this strategy in a few modern apex sharks, like the great white and mako. They don't waste energy keeping their whole body warm. They use special blood vessels to heat the important parts: their eyes for better vision, their brain for faster processing, their swimming muscles for explosive power, and their stomach for rapid digestion. The old image of a slow, lumbering, cold-blooded giant was shattered. This discovery recast the Megalodon as a high-performance machine, a predator with an internal furnace. This one biological fact changes everything. It helps explain how it could be so active, so powerful, and so widespread. Its warmth gave it the power to outswim, outhunt, and outblast its prey. But the most terrifying part of this discovery wasn't just about speed. It was about efficiency. A warm body is a double-edged sword. It gives you incredible advantages in speed and stamina, but it comes with a massive energy bill. An engine that runs hot needs a constant supply of fuel. And based on this new evidence, scientists ran metabolic models that produced some truly startling figures. They estimate a large megalodon needed to eat nearly 100,000 calories every single day. This is where the story takes a terrifying turn. We used to think of the megalodon's jaw as its ultimate weapon, but this new evidence suggests we should see them as just a fork and a knife. Their purpose was to load the furnace. The real weapon was the furnace itself. The megalodon's diet consisted of the most calorie-dense food in the ocean: whales. We have fossilized whale bones scattered with megalodon's bite marks to prove it. But a single kill, say, of a 25-foot prehistoric whale, was a huge calorie prize. By eating a meal that big, the megalodon wasn't just satisfying its immediate hunger, it was stocking up for the long haul. Those same metabolic models suggest that after eating an animal like whale, a full-grown megalodon could have potentially survived for up to 2 months before needing to hunt again. Imagine what that means. This wasn't a predator constantly on the prowl because it was starving. This was a predator that could methodically and patiently manage its energy on a global scale. The ability to fast for extended periods completely reframes how we see the megalodon. It wasn't just an apex predator, it was a transoceanic super predator. Its warm blood gave it the ability to leave the balmy equatorial waters and travel into cooler zone areas where its cold-blooded prey would become sluggish. A single whale killed off of the coast of ancient California could hypothetically provide the fuel for a 2-month journey across the open Pacific. This wasn't just aimless wandering. This was strategic fuel-efficient global dominance. The terror of the Megalodon wasn't a constant nagging threat. It was the certainty that somewhere out there, a fully fueled, 50-ton, warm-blooded predator was always cruising. It could be 10 miles away or 1,000. It didn't need to hunt today, or tomorrow, or even next week. It had time. This metabolic secret transformed it from a simple monster into a relentless, planet-spinning presence. Its jaws were a moment of violence, but its metabolism was for a reign that lasted for millions of years. Armed with its metabolic superpower, the Megalodon didn't just live in the ocean. It ruled them. For roughly 13 million years, from the Miocene to the Pliocene, it was an apex predator without equal. Its ability to generate its own heat opened up vast new territories. While other sharks were stuck in the warm shallows, Megalodon could follow whale migrations into cooler, more productive waters, giving it a hunting ground that spanned the globe. Its teeth have been found in marine deposits nearly worldwide, a testament to its incredible range. This was a different kind of predator. Some scientists now believe its warm gut acted as a powerful digestive engine, allowing it to process tough meals like blubber and bone with incredible efficiency, wringing out every last calorie. It was a swimming fortress, a self-propelled power plant built for endurance. This relentless pressure was likely a major force in the evolution of whales themselves. Some species grew larger, perhaps as a defense. Others may have evolved greater intelligence and social structures to try and outwit the great shark. For millions of years, the Megalodon was a central organizing principle of the marine ecosystem. But its greatest strength, this incredible high-energy, warm-blooded engine, was also its fatal flaw. A high-performance engine needs high-octane fuel, and lots of it. The Megalodon was a specialist, perfectly adapted to a world teeming with large, fatty whales. As long as the buffet was open, its reign was absolute. But the world doesn't stay the same. Around 3.6 million years ago, the planet began to change. The climate started to cool as the ice ages approached. Glaciers formed at poles, and sea levels dropped. These changes had a catastrophic effect on the Megalodon's world. The warm, shallow coastal seas that served as nurseries for its young began to disappear, and more importantly, its food source started to vanish. The diversity of the medium-sized baleen whales it preyed on plummeted. Suddenly, the buffet was closing. The Megalodon's high-maintenance metabolism became a crushing liability. Its massive daily calorie requirement was getting harder and harder to meet. At the same time, a new competitor showed up, the ancestor of the modern great white shark. Smaller, more adaptable, and with less demanding metabolism, the great white could get on smaller prey like seals. While Megalodon needed a whale, the great white was happy with a tuna. The Megalodon was an evolutionary masterpiece, built for a world that was disappearing. Its warm blood, the very secret to its long and successful reign, became an anchor. The leading theory is that it was too big, too specialized, and its internal fire was too demanding for a cooling world of diminishing returns. It couldn't adapt. It couldn't downwise. it was outcompeted and likely survived into extinction. The king was dead, not killed by a bigger monster, but undone by the cold math of climate change and a collapsing food web. The story of Megalodon is so much more compelling than what we ever thought. We were so fixated on the size of its teeth that we missed the furnace roaring behind them. It wasn't just a brute, it was a marvel of biological engineering. A hyper-efficient, warm-blooded super-predator whose dominance was written not just in violence, but in the quiet, relentless efficiency of its own body. The discovery of its own partial warm-bloodedness has reshaped our understanding of this prehistoric icon. It helps explain its global reach, its massive size, and its long reign. But it also gives us a powerful lesson. The same trait that fueled its rise, that incredible, energy-hungry internal fire, was the very thing that made it so vulnerable when the world changed. Its jaws were for killing, but its metabolism was for dominating the planet. And in the end, it was the same fire that burned out. The terrifying secret of the Megalodon isn't how it killed, but how it lived, as a perfectly tuned engine of destruction whose time inevitably ran out. What other prehistoric secret should we uncover next? Are there other ancient monsters whose stories need a rewrite based on new science? Let us know in the comments. And if you want to keep exploring the deepest mysteries of the past, make sure to subscribe and hit the notification bell. You never know what secrets the fossil record will give up next.